All right, you ready? How to divide things. So remember, we have like, if you remember this from way back in the day, you have a dividend, you divide it by a divisor. You're going to get a quotient, and then you're going to get a remainder that's divided by that divisor again. So that's like your fractional part left over. So let's say, let's make up our own. So we have like 453. Where's my little divided by symbol? Divided by 4. Okay, so that's going to be my example, right? So the first thing that I'm going to do is switch it over to kind of our world, which is going to be 453 divided by 4. So I'm going to write it out in fractional form. Now, we're going to go ahead and go do this just like we did when we were kids, right? So, so there you go. So I got a 4 on the outside. I got 453 on the inside, right? And you go, okay, how are we going to do this? So how many times does 4 go into 4? Well, it goes in once, right? 1 times 4 gives me 4. And then what do? I change the sign, right? I'm going to change the sign. And now I'm going to add down, okay? Dang it. Okay. And when I add down, okay, let's make a little underline to it, just like we're writing on paper, right? And then you'd get a 0 here, right? Okay. And then what would you do? You'd bring down that next number. So let's bring down that next number. What do I got? I got a 5 there. How many times does 4 go into 5? Well, it goes in ones. 1 times 4 is 4 again. Right? So I'm going to get a 4. Now what do? I change the sign. So remember, I need to change the sign. So let's put that in blue. So I change the sign, and then I add down. Okay, so when I add down, what? I'm going to get a 1 here. Okay, now I do the next drop, don't I? So I do the next drop, and I drop that 3 there. So I drop the next number. 4 goes into 13. It's going to be 3 times. 3 times 4 is going to give me 12, right? Again, I need to change the sign and then add down. So let's go change the sign. And then when we add down, we get 1, right? Okay, so and I don't have any more numbers to drop. That's the end of this. So, so this is like my remainder. This thing right here. Here, can I have an over arrow? That thing is my remainder. Okay, so what does that mean in my world? That means that this thing is 113, and then that remainder that was left over, over that original divisor, right? And so this is going to give me how we do long division, right? Cool? Okay, let's go over to something on the homework and take a look at this. Okay, now this gets a little bit awkward here because I'm missing an x. It would be nice if it x cubed, x squared, x number. So on this particular example, we're going to be slightly awkward, but that's okay. I'm good at being awkward. Okay, here you go. So we're going to set ourselves up. This same thing, okay? So what did you do here? You took like the top of the fraction and the bottom of the fraction, and you separate it on this little divisor symbol. So let's go do the same thing, right? So this is going to be this kind of numerator is going to go on the inside of here, but I have something odd that I'm missing an x term, so I'm going to put a 0 there. Is that cool? Everybody's cool with me? Okay. Are you ready? You excited? I can do this. What did we do here? We ask how many times does 4 go into 4, right? So we're going to do the same thing. How many times does x go into x cubed? How about can I say x squared times? It goes in x squared times, okay? What does that mean? Well, x squared times x would be what? It would be x cubed, yes? X cubed. Okay, there's my x cubed. Now, when I multiply x squared times 6, I'm going to get plus 6x squared, right? So, okay. But now I need to change the sign before I add down. So let's go ahead and go change the sign. Okay. And we're gonna change the sign here. We're gonna do the same thing. Okay, and we're gonna change that sign. And now we're gonna go ahead and try to add down. Okay, so let's go ahead and grab these items and add down. Well, this is going to be a 0, isn't it? So we just got to worry about this, which is going to give me a negative 3x squared. Okay, and then what? And then we're gonna actually bring down this next term. Okay. Which is going to be this 0x. Okay, so plus 0x. And you'll see why in just a second. Okay, how many times does x go into negative 3x squared? So I need a negative, I need a 3, and I need another x, right? So I need, let's just think about that. I need a negative 3x. And when I multiply this against that, that's going to give me what I need, right? It'll be that negative 3x squared. So it's going to be negative 3x squared. And then negative 3 times 6 is going to give me a negative 18x. Okay. Now, you see why I had that x there. I wanted this thing to match up. I don't necessarily have to do it, but man, I could get myself real confused real quick. Okay. We're going to go ahead and change the sign of these suckers, right? So you're gonna change the sign, and we're gonna add downward. Okay. And then what? So now that one's gonna 0 out, and it looks like I have an 18x. Cool. And then what? So, well, here they need to go and drop the next element, right? We need to drop this next element, which is going to be that 112. And how many times does x go into 18x? Well, it goes in 18 times. 18 times x is 18x. And 18 times 6 is, what's 18 times 6 is 108. Okay, and again, we're going to go change the sign, right? So, so let's go change our color. So this is going to be a negative. This one needs to be a negative. Okay, and as we add that together, that'll be a 0. This is going to be a 4, it looks like. Okay, so this thing actually is going to equal x squared minus 3x plus 18. Okay, and then our remainder is 4, so plus 4 over the x plus 6. Okay, this should be our answer here. So we get x squared minus 3x plus 18. And then the remainder is going to be just that 4 over x plus 6. I'm going to claim that's my remainder. Does it just want the 4? Okay. I guess so. All right, you ready? Okay, so that's cool. I got a whole bunch of cool methods, and let's do one. So this synthetic division. So check this out. So it's got a very specific architecture. You see, if we look at this real quick, what do we need? We need an x cubed term. Here, can I copy this? I need an x cubed term. Okay. I need what? An x squared term. Yes. I need an x term. I need a number term. Do you guys still use a hashtag as a number sign? An octothorpe. There you go. So these we're going to change over. So I want this structure. Okay. So just follow me here. How many x cubes do I have? Oh, hold on. I'm going to need 4 elements. You see how I need 2 rows, 4 elements? Okay, here we go. How many x cubed do I have? I have 1. How many x squareds do I have? I have 3. How many x's do I have? I have 0. How many numbers do I have? I have 112. Cool? Okay. What I'm going to put on the outside is what makes 0 in the denominator, that -6. The negative is going to account for how I have to keep changing the sign. You know how I have to keep changing the sign here? Okay. Okay. Just follow me. So the first element, I'm going to go ahead and drop down. Okay. So let's drop that first element. So that's going to be a 1. Okay. Now, -6 times 1 goes right here. So this thing here is going to be like, oh, here. So it's going to be like -6 times 1. Okay. Okay. And -6 times 1 is -6. 3 minus 6 is going to be a -3, right? So that's going to be a -3 here. Okay, that's fine. -6 times -3 goes here. So that's going to be 18. I add these down, so I'm going to get an 18 there. -6 times 18 was -108. And 112 minus 108 is going to be 4. Okay? You follow me? So now everything's going to get moved down. Oops. So this was x cubed, so it's x squared. This used to be x squared, so now it's just x. Okay? This used to be x. So now it's the number. This used to be the number. So now it's our remainder. You see what's about to happen? So everything got moved down a power, right? So this is going to be 1 of the x squareds. And if it's 1x squared, we don't really need that 1, right? So we've got an x squared minus 3x plus 18, okay, plus, and then our remainder, which is 4 over x plus 6. And this should be the same answer that we got here. Cool? Try these. You can do this.